You are cruising down the highway on a perfectly straight stretch of road. You take your hands off the steering wheel for just a second, and your car immediately and aggressively drifts into the next lane. You might just think the road is heavily crowned or the wind is pushing you, but what you are actually experiencing is a messed up wheel alignment that is silently destroying your vehicle. Wheel alignment is one of those routine maintenance items that gets constantly ignored by drivers until it is way too late. If your steering wheel is off center by more than just 2 degrees, you are essentially dragging your tires sideways down the pavement mile after mile. The first major problem here is the massive financial hit. Improper alignment causes extreme uneven tire wear, specifically feathering or cupping on the inner or outer shoulders of the tread. A decent set of rubber for a modern crossover or pickup truck can easily set you back $800 to $1,200. Burning through a brand new set of tires in less than 15,000 miles simply because your toe angle is out of spec is just throwing your hard-earned money right out the window. The second and honestly more terrifying problem is what poor alignment does to your handling dynamics. When your tires are worn unevenly, your actual contact patch with the asphalt shrinks dramatically. In a panic braking situation or on a wet highway, that reduced grip can easily cause you to lose traction, hydroplane, and put the car into a concrete barrier. And trust me, if you get into a major accident and the insurance adjuster notices your tires are completely bald on one side due to severe neglect, they might try to deny your claim. Most factory owner manuals recommend getting a complete four-wheel alignment done every 2 years, or roughly every 30,000 miles. But honestly, if you hit a massive pothole, clip a curb, or notice any sort of steering pull, you need to get the vehicle onto an alignment rack immediately. It is usually an $80 to $100 job that will save you massive headaches and keep you safe. If you want to keep your ride out of the shop and save some serious cash on your own repairs, go ahead and hit that subscribe button right now. Sometimes you might feel like your car is developing a mind of its own. You could be experiencing extremely harsh shifts, fake dashboard warnings, or random engine hesitation when pulling away from a stoplight. You naturally assume that your transmission is blowing up or your engine is failing, but the factory might have already released a simple software fix for your exact problem. These issues usually start off feeling somewhat normal, just a slight quirk of the car. Then one morning the transmission slams into second gear, or the engine bogs down hard at an intersection, and you wonder why your vehicle suddenly changed its entire personality. Modern cars are essentially rolling computers running dozens of separate control modules. Every single module executes millions of lines of code that dictate shift timing, throttle response, idle behavior, sensor sensitivity, and exactly how the anti-lock braking system reacts to a bumpy road. Over the years, engineers at the factory analyzed thousands of real-world warranty claims and driving data. Based on that, they quietly release updated calibrations that smooth out the transmission logic, prevent weird stalling issues, calm down hyperactive collision sensors, and fix phantom parasitic battery drains. The problem is, as a driver, you will almost never know these updates exist. Your car does not give you a push notification, and no warning light pops up on the dashboard. These critical updates are hidden away in technical service bulletins, usually just called TSBs, and are only accessible through dealership portals. A quick check of your vehicle identification number around the 50,000-mile mark can reveal a massive list of software improvements specifically written for your exact trim and engine package. So, if you are dealing with a violent first to second gear shift on a cold morning, a forward collision warning that triggers when the road is completely empty, a rough idle that almost stalls the car, or a battery that goes completely dead after sitting for a 3-day weekend, do not panic and start replacing expensive hard parts. Very often, a half-hour software flash at the dealership completely cures the vehicle. While we are talking about hidden maintenance, there is a vital fluid under your hood that you are almost certainly neglecting right now, and ignoring it can lead to total brake failure. I am talking about your brake fluid. Most people check their oil and maybe their wiper fluid, but they completely ignore the master cylinder reservoir. Standard .3 and .4 brake fluids are highly hygroscopic, which is a fancy engineering term that means they actively absorb moisture directly from the humidity in the air. Over time, water works its way past the microscopic pores in your rubber brake hoses and the seals in the master cylinder. Why is water in your brake fluid a massive safety hazard? Under heavy braking, like coming down a steep mountain pass or making an emergency stop from 70 mph, the friction material gets incredibly hot. That heat transfers right into the brake calipers and the brake fluid. Fresh brake fluid has a very high boiling point, but water boils at just 212 degrees Fahrenheit. If there is too much moisture in your system, that water boils, turns into steam, and since gas is compressible, your brake pedal will instantly sink all the way to the floorboards with zero stopping power. On top of that terrifying scenario, all that trapped water causes severe internal corrosion. It rusts the steel brake lines from the inside out and destroys the tiny, delicate valves inside your anti-lock brake pump. Replacing a ruined ABS module can easily cost you over $1,500. You should be checking the moisture content of your brake fluid with a cheap $5 tester pen and completely flushing the hydraulic system every 2 years or 20,000 miles to keep your stopping power exactly where it should. B. Another completely misunderstood fluid is your engine coolant, or antifreeze. It is one of those things you only think about when you see steam billowing out from under the hood, but letting the level drop too low or ignoring its age causes catastrophic engine damage. Just like the name implies, engine coolant absorbs the extreme combustion heat from the cylinder walls and transfers it out through the radiator to prevent the engine from melting itself down. If the engine gets too hot because you are low on fluid, the aluminum cylinder head will actually warp. When the head warps, the head gasket blows, allowing coolant to mix with engine oil, and you are instantly looking at a $3,000 to $4,000 repair bill. Furthermore, coolant is packed with very specific chemical additives designed to prevent internal rust, lubricate the water pump bearings, and stop the aluminum and cast iron components from eating each other through galvanic corrosion. When you neglect the coolant, those additives break down. The fluid turns acidic, starts eating away at your heater core, and eventually causes total engine failure. Skipping a $30 jug of coolant will literally buy you a new engine block. You need to be checking the coolant reservoir level every 3 to 6 months when the engine is completely cold. And if you ever need to top it off, you must use the exact specific formulation listed in your owner manual. If you mix an older green coolant with a modern orange or pink extended life coolant, they chemically react, turn into a thick brown jelly, plug up the entire cooling system, and destroy the motor. We are about to get into a super simple fix for a rough idle that mechanics routinely charge hundreds of dollars for. But before I give away that massive secret, make sure you hit subscribe so you never miss out on these garage tips. Let us talk about the mass airflow sensor, commonly known as the MAF sensor. This tiny piece of electronics sits right behind your engine air filter and has the incredibly important job of measuring the exact volume and density of the air entering the engine. The engine control unit takes that airflow data and calculates the exact amount of fuel to spray out of the injectors to maintain the perfect air-to-fuel ratio. However, when the MAF sensor gets dirty from microscopic dust particles slipping past an old air filter, or from excess oil if you use a washable aftermarket filter, it sends completely garbage data to the computer. The ECU gets confused and starts wildly bouncing the fuel mixture between too rich and too lean. You will notice the engine idle surging up and down, dropping so low the car shakes, or revving up by itself. This surging gets even worse as the engine warms up. You might also smell raw, unburnt gasoline from the exhaust, see black smoke out the tailpipe, watch your MPG plummet, and experience violent hesitation when you try to accelerate from a stop. Before you go replacing expensive fuel pumps or oxygen sensors, locate the MAF sensor on your intake tube. Unplug the harness, remove the 2 screws holding it in, and carefully pull it out. You need to buy a specific spray can labeled MAF Sensor Cleaner. Do not ever use brake cleaner or carburetor cleaner because the harsh chemicals will instantly melt the delicate plastic and ruin the sensitive hot wire inside. Generously spray the wire elements, let the sensor air dry completely for about 10 minutes, and reinstall it. This 5-minute job often completely cures a rough idle and restores your lost engine power. Right next to the MAF sensor is another component that causes massive drivability issues when neglected, and that is the electronic throttle body. In the old days, your gas pedal was connected to the throttle body by a physical steel cable. Today, it is entirely drive-by-wire. An electric motor opens and closes a metal butterfly valve to let air into the engine. Because of the crankcase ventilation system, hot, oily vapors are constantly routed back into the air intake to be burned off for emissions reasons. Over tens of thousands of miles, those oily vapors bake onto the back of the throttle body flap, creating a thick, sticky ring of black carbon sludge. When you take your foot off the gas to stop at a red light, the throttle valve is supposed to close just enough to maintain a steady idle. But that thick ring of carbon blocks the airflow. The computer panics, tries to force the valve open a tiny bit more, and gets stuck fighting the sludge. This causes the exact same stalling, rough idle, and sluggish throttle response as a bad MAF sensor. The fix is incredibly straightforward. Loosen the clamp on the main intake hose, pull it back to expose the throttle body, spray some throttle body cleaner onto a clean microfiber towel, and physically wipe out all that black sludge until the metal inside shines like new. Just doing these 2 quick cleaning jobs will make an older car feel like it just rolled off the showroom floor. Now let us cover a massive mistake people make every single winter. It is a freezing 20-degree morning. You jump into your freezing car, start the engine, and immediately crank the interior heater fan to the absolute maximum setting. You think you are warming the cabin up faster, but you are actually doing severe long-term damage to your engine. Here is the mechanical reality. Your car heater does not have an electrical heating element like a space heater. It pulls its heat directly from the engine coolant. A small radiator called a heater core sits behind your dashboard, and hot engine coolant flows through it to warm the air blowing on your face. But when the engine is dead cold, there is absolutely no heat to share. By turning the interior fan on full blast right away, you are basically acting as a giant cooling fan, pulling away the tiny bit of heat the engine is trying to build up. You are literally stealing the temperature the engine desperately needs to warm itself up. This keeps the engine in its cold start enrichment phase for much longer. The engine oil stays thick and sludgy, unable to properly flow and protect the tight clearances in the valve train and bottom end bearings. Because the oil is cold and the metal components have not expanded to their proper operating tolerances, you are causing massive premature wear to the cylinder walls. Plus, a cold engine runs a very rich fuel mixture, meaning you are burning significantly more gas and washing away the protective oil film on the cylinder walls with raw fuel. The smartest and safest thing you can do for the longevity of your motor is to leave the climate control completely off. Let the engine idle for about 30 seconds, start driving gently, and wait until the dashboard temperature gauge reaches at least the quarter mark. Only then should you turn on the heater. Let the engine generate its own heat first, and it will reward you with years of reliable service. Finally, let us talk about a totally free diagnostic and reset trick that does not require a single tool, a code reader, or even popping the hood. It is called the ignition key cycle reset. If you drive a slightly older vehicle, say from the early 2000s to the mid-2010s, and you recently replaced a dead battery or had some electrical work done, you might notice the car drives terribly. The throttle feels super laggy, the automatic transmission shifts at weird times, and it just feels sluggish. When the battery died, the ECU lost all of its adaptive learned memory. It forgot your driving habits and lost the precise calibration for the electronic throttle body. Instead of just dealing with a jerky car for weeks, get into the driver's seat and close the doors. Put your key in the ignition and turn it to the on position. This is the click right before the engine actually cranks, where all the dashboard warning lights illuminate. Leave it in that on position for about 3 seconds. Then turn it completely off. Repeat this exact sequence 3 times within 10 seconds. Turn it on, wait, turn it off, on, wait, off, on, wait, off. In many older vehicle platforms, this specific sequence acts as a manual trigger to reset the fuel pump relay, force the electronic throttle body to sweep and relearn its 0 position, and reset the automatic transmission adaptive shift logic. After you do the cycle, Start the engine normally and take the car for a 10-minute drive around the block, hitting different speeds and gears. The computer will quickly learn the fresh data, and those harsh shifts and throttle hesitations will completely disappear. It is a completely safe method that requires zero tools and works wonders for resetting the baseline algorithms on older car computers. Taking care of your car does not mean you have to be a master mechanic with a massive toolbox. It really just comes down to paying attention to the details, understanding how the fluids interact with the mechanics, and not ignoring the subtle warning signs your vehicle gives you every single day. I want to hear what is going on with your cars. Drop a comment down below and tell me what you are driving right now, what weird check engine codes you are getting, or what kind of MPG you are seeing lately. Let us get a conversation going in the comments. And do not forget to subscribe for more wrenching secrets and garage tips. Catch you on the next one.